In this video, I will demonstrate how to use the Data Point Zoom module of Magellan's Compass software. As mentioned previously, Compass is on a server that I access through a browser. Outside of this tutorial, you can use the internal help bubbles for support while using the software. In the prior video in this series, I showed how to use the cluster analysis module. At this point, we have identified data points or groups of data points that are highly connected to the biological difference between the samples and may have interesting relationships to each other. We now want to look at individual data points more closely. In this project, I am working with data generated from the NCI 60 cancer cell lines. I'm comparing replicates taken from two different breast cancer cell lines. As mentioned in prior videos, this is published data and you can access it at the PRIDE data repository. We set initial parsing resolution in the Parse Example subset module. That parse resolution was set to 0.2 Daltons along the M/Z axis and 40 seconds along the retention time axis. The instrument is far more precise, and we can now increase the resolution here and reparse the mass spec files. There are several user-defined parameters to set here. First, the machine learning classification bars can be used to select which specific examples will be selected in the reparse. Here I have selected two examples that machine learning correctly classifies with high confidence, as well as the example that is classified with the lowest confidence. I can then compare the mass spec data within each data point across these examples. Next, there are fields where I can specify the dimensions of the halo around each data point. Here I have used the default halo parameters of 2.4 Daltons in the M/Z dimension and 10 seconds in the retention time dimension, expanding the region of interest in high-resolution analysis in all four directions. This allows the user to see data that falls outside the region of the data point, ensuring that differences across examples are not due to signals that move in and out of the region of interest in different examples. I can also allow the user to visualize the distance between isotopes of the same signal and thus charge state, the Z in M/Z. Finally, I can set the M/Z and retention time resolutions as with the Parse All Examples module. Here I am increasing resolution 20-fold in M/Z to 0.01 Daltons. The user is only limited by the resolution of the instrument at this step. That said, be aware that increasing the resolution of the reparse above that of your screen may create information that is invisible. Compass will now reparse the files for the selected examples at the new resolution. All the data points emerging from machine learning are presented in a list, cataloged by their original M/Z and retention time coordinates, and ranked by machine learning importance scores. The fourth column is the internal ID of the data point. Each data point in the list can be viewed by a simple click, which drops down the high-resolution mass spec image. For each example, two-dimensional and linear plots are presented. The two-dimensional plot shows the M/Z and retention time space with abundance intensity colorized green. The white box indicates the original data point, and the gray area is the surrounding halo. The vertical tick marks on the M/Z axis mark 0.1 Dalton spacing, with larger marks for 0.5 and vertical lines for 1 Dalton spacing. Below and to the right are the projections of total abundances across the region on the M/Z and retention time axes, respectively. Given that large abundances in the surrounding area can cause scaling issues within the original data point region, the maximum abundance on these plots is set slightly above the highest value within the data point. Any abundance values that exceed that are depicted as saturated with a gray-blue color. Below the plots are additional visual outputs, allowing the user to see where the data points fall within the entire mass spec region analyzed. These tools are interactive in the same way as they are presented in the Select Best Data Points module. The function of the Data Point Zoom module is to allow user access to high-resolution mass spec data in regions that machine learning has picked out as relevant to the biology under study. The user can use the information for quality control, feature validation, or to see expected mass spec patterns, like isotope echoes. Up next, I will demonstrate how to use the Data Points to MS2 module.